Thanks everyone in the room and online for coming.
So far, I have been only showing you the single NEM devices, but the switch is not yet a technology. The question is whether we can bear large switch circuits and then let them to do something. So beyond single devices, we implemented 5 circuit prototypes, including the voltage two-time converter, the lookup table memory cell, the complementary NEM inverter, the switch box unit for the routings, and also NEM-driven CMOS and CMOS-driven NEMs. So first of all, we implemented a voltage two-time converter on an SOI wafer with a single 40 switch. And this 40 switch we implemented with a polymer plug with receiving contact, and the critical dimension is roughly 400 nanometers. So in this circuit, we use a 40 NEM switch to decouple the signal path from the actuation controller, so the input voltage alone sets the switching times. And eventually, we successfully converted a slow sine wave into a duty cycle modulated PWM output at 2 different modulation ratios. And second, we implemented a lookup table memory cell built with 2 30 NEM switch and 1 70 NEM switch. If you compare it with the microscale design, we have reduced the footprint by a factor of 8.5. So how does it work? If you see here from this neutral position, we can activate the 70 switch for both clockwise or counterclockwise and store a signal of 0 or 1. And with either of these 30 switches being activated, the circuit can read the 0 or 1 and then output. So we have also implemented the same function with the 3D integration approach with a further 5 times reduction on the footprint. And next, this is the first integrated circuit we implemented with the 3D integration approach. And the complementary inverter is the most foundational logic demonstration. And we implemented here with only 2 3T NEM switch. Since NEM switch is polarity independent, there is no N-type or P-type devices. One and the same device can work as both pull-up and pull-down switches, depending on how they are biased. And then on the same platform, we also implemented a switching box unit, and this is implemented by 4 interconnected 7-terminal NEM switches. And each of these switches, they can provide 2 signal channels. So for switches, we can connect 2 of them together, these 2 or these 2, and we can also connect 3 of them together, and also we can connect all 4 channels. So with those 4 switches, we can get 15 different routing configurations. This is very useful for the power critical routing because there is no need for multiple stack transmission gates to handle bidirectional signals because the 70 NEM switch itself is intrinsically non-volatile. After the initial test on the chip level, we also do the wire bonding on the devices for the following packaging and also the integration demonstrations. So finally, we have these NEM and CMOS transistors integrated together next to each other on the 3D integration platform. And this tool has been interfaced in both directions, so we can have both CMOS-driven NEMs, and we can also have the NEM-driven CMOS. And we finally come to the summary and outlook. So in this work, we first designed the miniaturization and optimization of the NEM switches for both 30, 40, and 70 configurations. And based on these designs, we implemented 2 different integration strategies, the NEM-first monolithic integration and the NEM-plus heterogeneous integration. And the second integration approach can give us a much better routing density through the vertical stack. In between, we also investigate the contact material and the contact shape for the NEM switches. Based on these two integration approaches, we implement 4 different types of circuits. First is the pure 3-terminal NEM switch circuits, and also with pure 70 NEM switch, and combined 3T and 70, and also the hybrid CMOS plus 3T. So my experimental work primarily demonstrates the process and device level scalability, and the full circuit level scalability to larger arrays remains a future step that's requiring some future work. Further improving the integration density on the CMOS platform, and also to further improve the reliability on the switch contacts. So thank you very much for listening, and I also want to send my special thanks to our project partners to make this work. Thank you very much.
Before we continue, we will have a 10-minute break. Okay, so we start again 20 minutes past 4.